This first problem states simplify, and then it has the expression, which has 6 times x to the negative 4th times y to the 7th, all in parentheses, raised to the power of negative 2. We are told do not leave any negative exponents in your final answer. To start, we're going to need to apply the rules of exponents for this problem. So let's summarize 4 of those briefly, the main 4 that we'll use here. The first is that if we have an expression a with base a raised to the m times base a raised to the n, then that's equivalent to base a raised to the sum of m and n. The second rule that we'll use is that if we have a raised to the m power, and then that's raised to the nth power, then that's the same as a raised to the product of m and n. Our third one that we'll need is that if we have the product of some expression or number a and b raised to the power of n, then that's the same as a raised to the power of n times b raised to the power of n. And our fourth rule will involve negative exponents, and that simply is that if we have a raised to a negative n exponent, then that's the same as the reciprocal, and so we're going to write that as 1 over a to the n. So the reciprocal of a to the n, with n being positive in that case. Okay, so to get started, let's take 6x to the negative 4th times y to the 7th, and again that's inside parentheses, and then raised to the negative 2 power. As our first step, we have a couple different choices here. We could apply rule 3 that I have written here as our first step. We could also apply rule 4 as our first step, and there are multiple ways to come up with a correct, fully simplified expression here. I'm going to start by applying rule 3. So what that says is that I can turn this into 6 raised to the negative 2 power times x to the 4th, or excuse me, negative 4th, raised to the negative 2 power, times y to the 7th, raised to the negative 2 power. From here, I know that according to the rule for negative exponents, I can turn 6 raised to the negative 2 into 1 over 6 squared. And then multiplying by x raised to the negative 4th, which is then raised to the negative 2 power, and I can use that rule that allows me to write that as x raised to the product of negative 2 and negative 4. So I'll have this then times x raised to the negative 4 times negative 2. And then lastly, that y to the 7th raised to the negative 2 power, I can also use that product rule there, and so that'll be y to the 7 times negative 2 in the exponent. Simplifying this, 1 over 6 squared is simply 1 over 36. X raised to the negative 4 times negative 2 will just be x to the 8th. And then this last one, y raised to the 7 times negative 2 is y raised to the negative 14th. I'm not quite done here. I need to not have any negative exponents in my final answer, and in general, I want to combine these as much as I can in terms of writing a fraction. So y to the negative 14th is what I want to work with here. So 1 over 36 times x to the 8th times 1 over y to the 14th when I apply that reciprocal rule for negative exponents. And then as a very last step, I can think of this x to the 8th, of course, that's going to go in a numerator here. It's x to the 8th over 1, and 36 and y to the 14th will go in the denominator. So this full expression will be x to the 8th over 36 y to the 14th. If you're looking for resources online or in your textbook, there are some key topics that you want to look for. So the key topics that are covered in doing this problem are the rules of exponents. So that's something you'd want to look up, and specifically negative exponents. So that's a subtopic there. So the rules of exponents and negative exponents are the things that you want to look up. And now I'll take you to a textbook where we can reference some of these. So I'm looking at a textbook called ORCA, ORCCA, which stands for Open Resources for Community College Algebra, and is a textbook written by PCC faculty that covers Math 60, 65, and 95. It can be found at spot.pcc.edu/math/ORCCA/ORCCA.html. So what we're looking for in here are some topics that will review the rules of exponents. And in this textbook, this can be found in Section 2.7, which has the introduction to exponent rules. And also, further on in Chapter 6, which would be from Math 65, exponent rules and scientific notation. Specifically, if we go to section 2.7, the introduction to exponent rules, there are videos in here, problems to practice, and if we scroll down, the summary of exponent rules are also here. For negative exponents, those will be in Chapter 6. And again, there's a summary of the exponent rules and problems that can be practiced. If you come down to what is exercise 6.1.19, this is a great example. So we've got all of the exponent rules covered. We have a summary of the exponent rules. And then if we come down, checking some exponent rules, and here's some that you can practice. So looking at exercise 6.1.19, which is one that you can try yourself, simplifying this, I can see that it should be 3 over x to the 4th, and so if I enter that in, 3 over x raised to the 4th, and I submit it, it's going to tell me if it's right or wrong. So I can try those on my own. If I want to just see the full solutions, I can click on the solution here. And so I'll go back to my original page here and summarize these. We were looking at, in that ORCA text, we were looking at section 2.7, section 6.1, and specifically that exercise 6.1.19 was a great one to practice.